Welcome to a code report data structures video. In this video, we're going to be covering 5 more data structures in 5 minutes. In the last video, we covered vector, set, map, unordered set, and unordered map. If you haven't seen that video, click the card in the top right-hand corner of the screen. In this video, we're going to cover stack, queue, priority queue, multiset, and multimap. Note that the first 3 aren't actually containers, they're container adapters, which means that they just wrap around other containers. For the first 2, stack and queue, the default container that they wrap around is dq, and for priority queue, the default container that it wraps around is vector. Our first data structure is stack. Stack is a last in, first out data structure. Its 4 most common methods are push, pop, top, and size. The complexity of these methods are all constant. Note that there's an asterisk next to the complexity of push. That's because push's complexity is actually equivalent to the complexity of pushback on the underlying container. But note the default container for stack is dq, and the complexity of dq's pushback method is constant. Taking a look at our code example, we declare our stack of integers. At this point, its size is equal to 0. We then push onto the stack the integers 1 and 2. At this point, the top method will return 2, as it was the last value that we pushed onto our stack. We then pop off the 2, and top will then return 1. On our final line, when we make our call to the size method, the stack will have a size of 1. Our second data structure is queue. Queue is a first in, first out data structure. Its 4 most common methods are push, pop, front, and size. The complexity of these methods are all constant. Note that the asterisk next to the push complexity is for the same reason as stack. Taking a look at our code example, we declare our queue of integers. At this point, the size of our queue is equal to 1. We then push on the integers 1 and 2 to our queue. The front method will then return the first value that we pushed on to our queue, which is 1. We then pop off the 1, front will then return 2, and on our final line, the size method will return 1 as the size of our queue is 1. Our third data structure is priority queue, which is essentially a heap. Its 4 most common methods are push, pop, top, and size. The complexity of these methods are log n for the first 2 and constant for the last 2. Note that when you make a call to push, you are essentially making 1 call to push back and 1 call to push heap, and for pop, you are essentially making 1 call to pop heap and 1 call to pop back. Taking a look at our code example, we declare our priority queue of integers. At this point, its size is equal to 0. We then push onto it the integers 3, 1, and 2. Because by default a priority queue is a max heap, the method top at this point will return 3. We then pop off the 3, top will then return 2, and on our final line, the size of our priority queue will be equal to 2. Our fourth data structure is multiset. Multiset is similar to set, except that it can have duplicate values in the set. Its 3 most common methods are insert, find, and size, and similar to set, the complexity of these methods are log n for the first 2 and constant for size. Taking a look at our code example, we declare our multiset of integers. At this point, its size is 0. We then insert the values 1, 2, and 1. At this point, our multiset contains all of those values, including the duplicates in sorted order. We then make a call to find, looking for the value 1. If 1 exists in our multiset, find will return an iterator pointing to that element. Otherwise, find will return an iterator pointing to the past the end element. Because 1 does exist in our multiset, our second last line outputs found, and on our final line, the size method will return 3. Finally, our fifth data structure is multimap. Multimap has the same relationship with map that multiset has with set. Its 3 most common methods are insert, find, and size, and the complexity of these methods are log n for the first 2 and constant for size. Taking a look at our code example, we declare our multimap where both the key and the value are integers. At this point, the size is 0. We then insert into the multimap 3 pairs, 1, 2, 2, 4, and 1, 3. We then call the find method looking for the key 2. Because that exists, our second last line will output the value 4, and our final call to size will output 3. Finally, in order to use these data structures, you have to include the following.
As always, if you enjoyed this video, hit that like button. Make sure to follow me on Twitter for reminders 30 minutes before contests start. You can find all of the code that I use in my videos on my GitHub page. All of the links are in the description down below. And finally, if you want to make sure you don't miss any of my upcoming videos, make sure to hit that subscribe button. Thanks for watching, and I'll see you in the next video.